All right, good afternoon, and thank you for coming to my talk on Microsoft patch analysis for exploitation. I'm not used to standing still, but they told me I have to kind of stay in this area, so I'll try to struggle through that. We'll see how it goes. But real quickly, I want to just kind of give a quick intro to what the talk will be about. So I'm not big on intro slides, so I'll just quickly give you a summary of who I am if you're not familiar with me. My name is Steven Sims. I live out in the San Francisco Bay Area. I grew up here, actually, and thank you to BSides for having me. I've been teaching for the SANS Institute for the last 10 years or so. I have a couple courses on exploit writing and advanced penetration testing. I'm one of the authors of Gray Hat Hacking, 4th edition, and we're working on the 5th edition now. I do a lot of consulting for security development lifecycle, as well as a lot of exploit development and vulnerability research, so selling exploits, things like that. So that's enough on me. This talk is going to be about taking Microsoft patches and reverse engineering them against a prior update to a particular file to try and see if we can discover the bug, the code changes that are related to the vulnerability. And the faster you can do that, then you can get a working exploit potentially, and most organizations aren't so good about patching very quickly. Or if they are, it's kind of inconsistent, or maybe they choose some patches to roll out but not others. And there's been a lot of changes over the last year or so with how patches are distributed, along with Windows 10. There's just been change after change after change. And then again, this month's patch for April, they changed it again. They've used a TechNet site for a very, very long time, since I can remember. You always used to go and get your patches on this one particular site, and now they just changed that to an MSRC location. So again, changes, there's more changes coming. So I'll kind of give you an update as to how that's going, because it affects the way we can extract and identify which files in a cumulative update are related to a particular security fix. And it just makes life a little bit more difficult there. First, a quick note on the operating system market share, because this comes up a lot, especially when you're doing things like anything from writing courseware to train to actually doing things in practice to find bugs. Some bugs affect many operating systems, sometimes all of them, and other ones only affect specific operating systems, like one might affect only Windows 10. I'll give you an example of that today. If you're looking for a vulnerability that's been patched, and you know that it's affected multiple operating systems, it's clear that it would be easier to reverse engineer the earlier version, the earliest version of Windows as possible. So Windows 7, for example, is going to be a lot easier to potentially find a security fix than Windows 10 64-bit Enterprise. That's not always the case, but it just seems obvious. I know some people still try and get the XP embedded patches that are still out there to try and look at those, because the code, it's just less code. So this right here shows you that I pulled this yesterday, I believe, and the Windows 7 market share is around 50% if this is accurate, right? Netmarketshare.com. So 50% of the market, clearly attackers are going to want to focus on the most heavily used operating systems, and 75% of the market is Windows 7 and Windows 10. And I'll tell you, as long as I've been doing bug research and vulnerability and exploitation, whatever you want to call it, it's been well over 10, 15 years. It is Microsoft Windows 7 is kind of like XP was to Vista and 7. Windows 7 is that to Windows 10 in terms of security. There's just underlying security problems that are inherent in the kernel and things that they can't change. An example would be a newer control that Microsoft believes very heavily and strongly in is Control Flow Guard. And Control Flow Guard, the idea is let's try to stop things like return-oriented programming by building a bitmap, basically a way of tracking all the valid entry points for functions inside a DLL or other file. And if someone tries to do an indirect call as part of their return-oriented programming attack or using that technique, it would say, no, that's not an entry point for a function, so therefore I'm going to throw an exception and terminate the process. It's a pretty effective control, so much that Microsoft believes that discontinuing the Enhanced Mitigation Experience Toolkit in July of 2018 is heavily mitigated by Control Flow Guard. And there's a lot of research going on now in the last couple of years on bypassing Control Flow Guard. And then we've got newer controls like edge detection and things like that, and control flow integrity and shadow stacks, all these things coming soon that we'll have to deal with as well. So my point again is Control Flow Guard is supported on Windows 10, and they backported it to Windows 8, but it's not supported on Windows 7. I don't think it ever will be. So there's a lot of inherent lacking in the kernel for exploit mitigations and the like that you can't do anything about until you upgrade to Windows 10. So that's the big push. But as you can see, half the world, which that translates, I'm sure, to billions of computers, are running Windows 7. Windows XP is still at 7.44%. So ATM machines, industrial control environments, some government environments they're still there. A lot of video game players in China intentionally stay on XP so that the video game companies like Riot Games, for example, have to support it, and then it makes it easier to hack. So things like that you'll see. Vista's not up there, sadly. I don't think it ever has been up there. The two people just had some bad news this month with the end of life for Vista, who use Vista. So real quick, application patching versus OS patching. We're going to look at operating system and library and driver patches to specifically the Windows operating system. Microsoft's had Patch Tuesday for a long time, back as far as like 2002, 2003, when Bill Gates sent out the Trustworthy Computing memo and Microsoft kicked off the whole security development lifecycle process. And it's been very useful. It's helpful for administrators to know that patches are going to be coming out at a specific time each month. They can plan for it. The newer models that they want to roll to are, of course, it's cumulative. They want to be able to push these updates constantly, and it's Windows as a service now, which makes life a little bit more difficult potentially if there's constantly patches rolling out and you've got to push them out, and if things break things, all that fun stuff. But anyway, application patches we'll really not focus too much on, but I'm going to do some demonstrations of binary diffing, and you could do that against applications. The problem with application binary diffing is there's usually so many changes that are unrelated to security vulnerabilities that it's just noise, and it kind of defeats the purpose of doing binary diffing, but not always. Some organizations will make it clear as to what a patch is for, like this is a security update to address a flash vulnerability. Other ones are not so clear. If you look at Apple and Oracle or whoever else versus Microsoft, you can see differences. Oracle, typically we have, quarterly updates. So Patch Tuesday, been pretty much talking about that already. The idea was to simplify the patching process, but it's understandable that there's going to be out-of-band patches when there are emergencies and 0 days discovered in the wild, as long as there's not too many of them. But one thought is, if I'm a bad guy and I discover a 0 day and I want to use it, it makes sense for me to start using it on Patch Tuesday, because then I can assume that it might take Microsoft up to another month to actually patch that vulnerability. So exploits are sometimes released the days after. Now, you might say, well, I don't hear much about it, and that's because there's a price tag on that. If Patch Tuesday occurs and I download the update, and I can quickly hone in on code changes and identify the vulnerability and get a working exploit, which is hard. But if you can do that quickly and it's lucrative, if it's something like Microsoft Office where you can do a client-side exploit, you're hoping that organizations and people, users, whatever, aren't patching quickly. And the faster you get that exploit written, the more value. So the return on investment is high the closer to the date the patch was released, and then as time goes on, more and more organizations will patch up to date, and that value will decrease. So if I go through and take the time to do that, and I'll just go back on another path, for example. If you were to sell, say, a couple years ago before Microsoft really spent a lot of time trying to mitigate use after free exploits, if you were to sell that to like iDefense, or ZDI, something like that, an ethical buyer, you could get $10,000, $20,000 for it. And nowadays, Microsoft spent so much time trying to mitigate that stuff, the value's gone up. If you can get around exploit mitigations like memgc and isolated heaps and other ones, then the price tag's going to be higher. But back to patch diffing, you're not going to get that much money. It's not the same as a 0 day, but they call it 1 day exploits, because if you can get an exploit written 1 day after the patch comes out, there's a good return on it. It's valuable. Because again, organizations don't patch quickly often, a lot of them. So you could still get money for that, or you could use it as part of your pen test or whatever you're trying to do out there with this exploit. There's also buyers out there, I'm not going to name any companies, but there are companies that make exploitation frameworks. We know who they are. And they want to be able to tell others that, hey, I've got more exploits for privately disclosed vulnerabilities than any of my competitors, so you should buy my product. And that makes sense. So some of these companies have a shopping list, and they'll put price tags next to it, and you can sell it to them. Windows as a service, real quickly, this started with Windows 10 primarily, where it was known that there were going to be cumulative updates, and I'll talk more about what these cumulative updates mean a little bit later. Windows 7 and 8, they also wanted to push those operating systems towards using cumulative updates as well. And again, I'll explain more about that. Microsoft, they test in their lab environment new features, new rollouts and services, things like that in the Azure cloud, on a fully patched system. They want to know what state your system is in so that they know when they do things in their lab, it's going to match what's out there in the real world. And that's a hard thing to do. Up to date, organizations get to pick and choose when they want to roll out patches and which patches they want to roll out. And Microsoft may never know what kind of state you're in. It's kind of like when you're doing regression testing or even quality assurance in a development lifecycle. You're trying to test your application under every condition possible, but that's impossible. So Microsoft wants to be able to get as close to that as possible. These cumulative updates are supposed to supersede the prior month's update. And with Windows 10, that means if you were to update April's 2017 on an unpatched Windows 7 box, it's got everything you need to get you up to speed. You don't have to go start at 1 and then go to 2, then 3, then 4. It's all there. And they're trying to get the other operating systems to follow suit as well. So this is what I mean. It's a graphic I took from Microsoft, straight from their information talking about this. On the right, that's what it looks like. Those squares are patches, basically. And on the left, you can see that's a typical business, is what they're saying. A typical business, even though the business is saying all of our systems are patched up to date, they may have chosen certain updates to not apply because maybe it affected something in the organization. They're afraid to roll it out. So even though they say they're up to date, they're not 100%. It's kind of scattered like that on the left. So that's why it never gets old, or it's always still a good thing to do when you're doing a penetration test, to use things like PowerUp and those PowerShell scripts and things that basically tell us what kind of vulnerabilities might be there on the system. Even if it is patched up to date, it's probably missing something. So these servicing branches, I don't want to spend much time talking about this, but again, it's all about they want to force the updates on you. If you ever play Xbox and there's an update required, you can't log on to Xbox Live until you apply that update. They can do that with Xbox, and they'll log you off until you apply it. That's what they want to do here. And again, it's all about making people more secure and getting them in that known good state so they know their features are going to work. So they have this current branch, which is good for developers and things like that who need to test the applications to make sure everything looks good for compatibility issues. They've got the current branch for business, which would be your typical organization. That's what Microsoft wants you to be under, so that everything is up to date, and you've got some ability to defer patch updates, but not much. It's like 30 days or something like that. But everything I'm saying could change. It's been changing every month, and it's complicated, and people are getting frustrated. The other one down at the bottom, long-term servicing branch, that would be you can defer a couple years, and that would be on embedded systems like MRI machines or maybe ATM machines, because, that's good, and things like that. Patch distribution, this can change as well. It's all very live state right now. Windows Update, when you get your updates for your computer, you typically have an organizational patch management solution like WSUS or something like that. And your workstations are configured to use your company's update service. And you can push out what we want when we want it as an administrator. Of course, independent systems, if they're allowed, can go out to Microsoft and patch independently. And then when you're reverse engineering patches, so someone like myself who wants to get them every Patch Tuesday, we want to be able to go to a website and download these patches. And it used to be, when you would download the patches, the patch you're looking for tied to a knowledge base number or a CVE would be for that specific vulnerability. And what you're downloading, sometimes it's as small as 100K. Tiny little file. And it's just kernel32.dll or just the driver or whatever that's affected. And that made life real easy, because then you could download the new one, go to the prior month's update, or at least the most recent time that same file was updated, and you can diff the two, and that's what I'll demo soon. You can diff them, and you're hoping that very few changes were made, and it makes it real. It's like a flashlight pointing at you. It's like over here, and you can see exactly what the code changes are in disassembly, and then of course you can decompile from there. But with the newer ones, it's all rolled up together, and it's kind of ugly, and I'll talk about a solution there that Greg Linares came up with. So Windows Update for Business is specific to Windows 10 if you want to go that route. So I'm just moving along here quickly so I can get to the good stuff. But it's important to understand where things are going. So reverse engineering updates, that's done by the good guys, the bad guys, and everybody in between. And of course, it's all about finding the vulnerability and being able to get code execution. Sometimes it's easy, and I'm saying that relatively, and sometimes it's ridiculously hard and time consuming. For example, if you were going to download edge.html or mshtml.dll for Internet Explorer 11, and you try to do a diff on that, a lot of times there's anywhere from 10 to 50 patches, security fixes in that one DLL for the browser to deal with things like use after free or type confusion bugs. And doing a binary diff of that, it's just a nightmare. You're trying to find the code changes, but there's so many code changes that it becomes hard. So it's easier when you're doing things that are not browsers and such, but it's still very lucrative. You can also diff drivers. The nice thing about a lot of Microsoft products is they give you the symbols. So the symbols are the function names. And internally, when a programmer is writing code, they name the functions things that are useful, that are meaningful to people, like load cursors and icons, and we know what that function does. But once we compile that, we don't want people to easily reverse engineer and know what that function does, so we strip it. And then when someone's looking at it, all they get is a memory address, and they have no idea what that function does. Well, Microsoft, for a lot of their products, will provide us with the symbols, and we can download them, and we get to see all those internal function names, which makes life a lot easier. I know most people that reverse engineer malware would love to have the symbols. But when they don't have to give you symbols, they don't. Like for Microsoft Office Suite and such, the developer in a typical organization who's writing an application to work on Windows doesn't need the symbols for things like Office. But they do need symbols for things like NTDLL because that's the gateway into the kernel. So reversing patches is a very acquired skill. If you want to get into it, it's best to start off simple and then ramp up. I joke and say all the time, you've got to suffer through it like we all did when learning how to reverse engineer. There is no magic course or anything that can make you an expert at programming in C++. You can be programming in C++ for 10 years and still not be an expert at it because it's a complicated language. So obtaining patches up until this month, because like I said, it changes constantly lately, you would just go to TechNet, as I mentioned earlier, and you could type in, like the easiest way is go to Google and you just type in MS17010, and it would take you straight to the TechNet link for that specific update, like you're seeing up here. This one's for MS17004. And if you were to scroll down, you would see the patches that you could download. Now, it used to be those were the patches for that specific knowledge base number, that specific vulnerability. But now it's cumulative, so you can't just download typically one patch. You're getting every patch that's associated with that month's update, or if you're dealing with Windows 10 and where Microsoft's going forward. This changed. It was October 2016 when Microsoft tried to roll this same kind of cumulative updates out for Windows 7 and Windows 8. And the idea is if you were to get the patch in October, then you're downloading all the patches in one file, the security fixes anyway. And then when you go to November's patch update, it's got October and November's patches. And then so you would think the files are going to get bigger each time. It's been kind of inconsistent, but Windows 10 has always been that way. Windows 10 has feature updates and security updates in the same cumulative update, and they're very large, as I'll show you in a moment. So we could go here, choose our desired operating system that we want to download the patch for, and then we've got the patch. We'd have to extract it then. This month, they changed it again, and now you've got to go to msrc.microsoft.com to see the updates and get the patches. So this is the first month that that's changed. It's really complicated. I don't know why they did it this way, but there's search bars and such where you can try and find the vulnerability disclosure that you're looking for, the announcement, but it's a lot of noise. I mean, tons of the same hit over and over again. I really don't like this particular way that they're doing it right now, and hopefully that changes. You could actually get the vulnerability information on the bottom link. The upper link is where you have to go to start doing your searches and such. And then from there, you'll find a link to be able to download the actual cumulative update. So types of patches, back in the old days with XP and Windows 2000 and 2003, they were executables. So the patches you would download, it's just an executable, you double click it, and installs it, replaces the old file, and puts the other one into a backup location. And you would extract it with the extract tool in DOS or command line. On Windows 7, Vista 7, 8, 10, whatever, they're MSU files, and you've got to extract them with the expand tool. So I'll show you this in a moment. Here's the command you would run, expand -F, and then you say expand everything, give it the MSU file, and then once you do that, there's a cabinet file. You would have to then do the same extraction method on the cabinet file. So here you can see we're extracting the cabinet one with the expand tool. And we're running a dir to look and see what changes are in there, what directories are in there. And you can see there's one for user32 and one for Win32K. So Win32K is a driver file. It's actually the kernel side of the Windows subsystem. CSRSS.exe would be userland side. And then we've got user32 updated as well. So in this next slide, I basically just go in, change directory to the one for user32, and we run a dir, and you can see there's the patch right there. So user32.dll, that's the patch file. You'd want to diff that one against the prior update to that file. They used to make it real easy where you could go on the site on TechNet and you could say updates replaced by, you could click on it and find the most recent time that that same file was updated, extract it, and diff it same way. So extracting cumulative updates, which is where we're at today, I was talking with Greg Linares, who's Laughing Mantis on Twitter back in October, and he was working on a PowerShell script called patch extract to go through and extract everything out of these cumulative updates, because again, it's a ton of files. To give you an example, you'll see on the next slide or two, the Windows 10 one is around a gig for 64-bit. So you're downloading a 1 gig cumulative update file. And when you extract that, there are thousands of files in there. And making sense of that and organizing it and getting rid of all the garbage that you don't care about and manifest stuff, it's annoying to do it by hand anyway. So he wrote this patch extract tool, and that's exactly what it does. It extracts everything and gets some organization in there. And then there's also a tool he wrote called patch clean. Patch clean's quite simple concept. It goes through the extracted files, looks for files that have changed in the last 30 days and puts them into one directory that says these are the ones you should care about because they've been updated in the last 30 days. And then it puts everything that's older than 30 days into an old folder. And that way you're honing in on that month's updates. So hopefully you see why that's useful. You've got a cumulative update of thousands of files, tons of patches. It extracts everything, makes sense of it, and then you run patch clean so it only points out the files that have changed in the last 30 days so you know that those are the ones associated with this month's updates. So it's a very useful tool. And here's that example I was talking about. It's over 1,000 megs, so it's almost a gig for the 64-bit Windows 10 update. That same month, so April, Windows 7's update was only around 100 megs. So big difference in the size, and that's because Windows 10, they truly are cumulative with the features and everything from the start. So patch extract, I'll just demo this here in a moment, but it takes a while to run. It's expanding and doing a lot of stuff, so you can expect it to take around 10 minutes, depending on how big that file is that you're extracting. So the one that I'm going to do here in a moment, and we'll have to let it run in the background because it still takes a couple minutes, will be for Windows 7, so it'll only be for that 100 meg file. So you would run this PowerShell command and use the tool and basically tell it where you want it to extract to. Then when you run patch clean, you can see that it narrows it down and says high priority folders 16 versus 3,810 low priority folders. That's showing you that you want to focus on those 16 folders because those are likely the ones associated with this month's patches. So a huge time saver right there. So I'm going to jump over to Windows here. And I've got it set up and ready to run the command anyway. I need to change my date because today is not Patch Tuesday, and you'd want to make sure it's saying 30 days from Patch Tuesday back, or you're going to miss some. So I'm just going to change my date here to Patch Tuesday from this month. That would be the 11th. And now I'll let this command run. So you can see the knowledge base number. Over here you'll see a bunch of stuff start to show up. But this again will take some time, so we're going to let it run in the background. And once it's done expanding everything and cleaning up, then I'll switch back over to this and we can run the patch clean tool and see how many files we're left over with. It all depends. Like February's patches got skipped, if you remember, and that's because of some interesting things with the SMB bug and how Microsoft was informed about said bug. And so they skipped a month, and March was the next one. So March's update was massive, and we have April's now, of course. So I'm extracting April's update. So while that's running, we'll go back out here. This would be the result, though, that I'll show you in a moment. This is not the same one I'm extracting now. This, I believe, is January's updates. But you can see that we've got 19 directories that it pointed out as interesting. So all those ones that are put into the old directory, we don't have to care about. This right here, so a next question while we're letting that run in the background is, how do you map an extracted update to the KB number or the CVE? In other words, if I'm left with 20 folders and those 20 folders have patched files in them, like DLLs and drivers, how do I know which ones map to the knowledge base number, the vulnerability that I'm interested in researching? Well, here's just an example where we see a security bulletin, security update for Microsoft Edge. And since we're only left with a little bit of a small number of folders, we got to kind of infer. So we see a file there for IE HTML rendering, and we go in there and it's edge.html. So common sense would have us say, well, that's probably the one associated with that. And I'll show you another example of this in a moment with a demo. So it's still running in the background, so we'll let that go. So while that's happening, I'll explain patch diffing. Patch diffing, as I already mentioned, is we take one version of a file and we diff it against another version of a file. And there's a bunch of tools that can help us do this. I'll talk about them in a moment. And I'm going to use bindiff, which was originally written by Zynamics, which was Halvor Flake or Thomas Dullian's company out of Germany, but Google acquired them a number of years ago, so now it's owned by them. And they release it for free now, which is nice. So security patches are often made. We hope that they're not feature updates. We don't want to be looking at feature updates because we don't really care about those as far as a diff is concerned. When a new version is released, it's hard to know what code changes are related to a specific vulnerability. Sometimes Microsoft's more generous with the disclosure. So they might say, I remember there was one for TCP/IP and it said TCP fin weight vulnerability. Well, that's helpful to me because then when I'm doing a diff, I can look at the symbol names, the functions, and say, hey, there's a function called TCP fin acknowledged, and the vulnerability disclosure is called TCP fin weight vulnerability. So we can put that together, right? Other times they're very discreet or they don't tell us anything, and it makes it more difficult. So some vendors make it really clear and they're very helpful with what they're fixing. Other vendors are not good at all about it and they don't want you looking at their stuff. So some of those tools that I was going to talk about, we've got Zynamics, bindiff, again acquired by Google. That was free as of March last year. Core Security had a tool called TurboDiff that's been around for a very long time and that's free. Darngrim 4 by Hyungwook Oh, which is Matt Oh. He went to go work for Microsoft like a year or so ago, maybe a little bit longer, so he stopped doing development because Microsoft asked him to stop doing development on that tool. That was a neat one where he made it as a standalone tool. You still had to have IDA, the interactive disassembler, but you could export your results into IDA and do some color coding that was really neat. PatchDiff 2 is another one that's free, which is nice. You still need a licensed copy of IDA. If you don't have a licensed copy of IDA, you have to use Core Security's TurboDiff with the free version of IDA, which is IDA 5.0, which is quite old now and slow. Diaphora is a great tool written by Joxine Corrette, who's written tons of really great tools and gives away a lot of free software. That one's at least actively maintained, and it is written in Python, so it's going to be a bit slower. It's not C++ like bindiff is. Bindiff's very fast. Diaphora is great, uses tons of heuristics to try to identify the code changes. That's one of the big questions, right? How do these tools actually know when there's a code change? And it's a combination of things like string matching and name matching, which is the easy and obvious ones. And then it goes through and uses different types of heuristics because it gets complicated in where a compiler or an assembler might assemble the code differently even though it's the same code, depending on, how it's feeling that day, or what kind of features and compiler flags you use. So if the assembly, it looks different when you compile it 2 different times, you want a tool that's smart enough to know, hey, if this says we're going to zero out this register, that's the same thing as subtracting something or negating it once it's this value. Or there's different ways you can have that same result. So we want something that's smart like that. And Diaphora has some really great heuristics that it uses. So this is done here now. And if we look in the results, let me zoom in. You can see that this is what we're left with. And this was the x86 version of the patches because I wanted to keep it relatively small. So we go in here and there's a ton of files. So we scroll down and you can see lots and lots and lots of stuff. So wouldn't it be nice to have a tool that goes in and cleans that up a bit? Now we still may be left with a lot. It depends on the month's updates and other things, but let me go ahead and run patch clean against it. And we'll see what we're left with. So I'm typing minus path, and then the path to the patches. So run this guy. This one won't take as long as the last one, but it's moving things around. So what we hopefully will see is this shrinking on the left. What's done? So we're left with high priority folders 56. So it moved 491 of those folders into the old directory, which is very useful. We can zoom in here, and we can see, if we scroll down, there's not many left. There's the old folder. And you'd want to try and correlate. So these all say IE on the front, so we probably assume they're related to Internet Explorer. Scroll up top, tons of them are IE. And again, here's GDI up there, so GDI 32. There's a patch file, so a DLL. So zoom back out. We'll go back out here. This is an example of results when we do a graphical diff, a visual diff, using the bin diff tool. And I'll zoom in a moment when I actually demo this a bit, but what you see is on the left is one version of the file. Typically, I like to put the unpatched version on the left and the patched version on the right. And when you identify blocks that are green, as you see up there, the color coding depends on a tool, then you know that the blocks are the same between both sides. When you see yellow like that, you can't really see it. I'll try and zoom in so you can see. When you see yellow, it means there's code changes inside. So you can barely see it, but there's a little blue highlighting right there. That doesn't exist on the other side. So you know the block exists, but there's a change within the block to the assembly. And then if it's a red block, then you know that that block doesn't even exist on the other side. And you'll see a lot of that when I demo it here in a moment. So here's an example of a patch vulnerability, and I'm just instead going to demo this instead of showing on a slide. So let me jump back over to Windows. And I'm going to start up IDA64. And I'll keep zooming because I know that it's a little bit small on the screen. But right here, I've got a folder set up for MS16009. And I go in there, you can see I've got the patched and the unpatched version. And I had to get this out of a cumulative update. It was from last year for Windows 10. This one specifically is for Windows 10 64-bit. So we'll go into the unpatched version here. And you can see I've diffed it previously. There's the IDA database file. So I'll just double click on that to bring up IDA. And I'll zoom out here. So here we have IDA. If you're not familiar with the tool, it's a great tool. It's a learning curve, of course, because it's a complicated tool. You kind of have to know how to read disassembly, but it's extremely powerful. And if I show you on the left here, you can see all these names. That's because we have the symbols. Microsoft gave us a symbol for this DLL that we're looking at and makes life much easier. That's an interesting one. Should URI be... Anyway, this right here, I joke and say it looks like Extreme Donkey Kong, but this is a disassembly of a function. And if we zoom in, you can see the disassembly there. And these are all blocks. Blocks typically have something called edges. And an edge just means we get down here and it says jump if 0. So we can take two directions. We can go that way or that way. And that's going to be based on the result of some arithmetic or some comparison or whatever else that's going on. And then you can double click on this and say, well, we would have gone to here had that been true on the one side versus false on the other side. So that's just, I don't really have time to go into the depths of IDA right now. But again, very useful. I'm going to now bring up bin diff here, and we're going to diff against the patched version. So go in here. I don't know why it's taking me there. That's not where I want to be. Give me a moment. So patched, and we go like that. And it's pretty quick. Again, C++, so it's not going to take very long. It's going through the IDA databases and comparing and trying to identify those code changes using various heuristics like we talked about. Once it's done, it's just about finished here. Up on the right, we'll get a bunch of new columns. And I'm going to shut down most of them because we don't need them. There it is. So I'm going to close the ones we don't need. And this guy's the one we do need. So what you see here, when it says similarity, those are the function names over here on the right, and it's saying that they're identical. So the patched version versus the unpatched version are identical. And we scroll down, You can see most of them are identical. So we click on similarity to sort it, and we scroll up. There was only one function out of 4,500 with a code change. That saved us a little bit of time, right? Having to go through that manually and looking for code changes. So now we'll do a graphical diff. We'll go and say Control E and bring up a graphical diff of it. Now this is a large function, so it's going to take me a moment to find the spot. But that's the side-by-side comparison now. And over on the patch side, I'll just shrink this down. It's really small. I'm going to duck my head for a second so I can find the bug. Hold on. There it is. All right, so right here, let me zoom. This was a DLL sideloading bug. And on the left, on the unpatched version, you can see DW flags. DW flags, when we pass it to a function called load library exa, we are asking this particular code block here to load a module. We want to load some DLL into the process because apparently it needs it. With DW flags, it allows us to specify where could that DLL be located. So Microsoft implements something in MSDN, you can see it called Safe DLL Search Ordering. And it's kind of like if you were in your house and you knew that the salt is typically in a particular cabinet, and you open up the cabinet and you look in there and it's not there. You go looking for it, right? You go to the next cabinet, you look in the closet, you look on a table, and you go around until you find it. And eventually you give up, you'll exhaust. And that's kind of what we do when we search for DLLs if they're not where we expect them. The DW flags option in this one, you can see it's being, I'd have to zoom over a little bit, and I don't want to try and grab on this or it might fly. I'm going to try it. Hold on. Maybe we'll get lucky. Oop. There we go. So see how it's saying XOR R8, that's register 8, 64-bit. It's zeroing it out. So we're passing a DW flags argument of 0. And that means go look for it anywhere you can find it for the most part. I mean, there are limitations, but that's when we get into trouble. If you've ever run a tool like PowerUp with PowerShell, and it says, I found a DLL hackable or hijackable location or something, what it's doing is looking for things in your system path and other areas. Like if you install Python, Python's automatically in your path. And if someone can get a DLL that's involved in a DLL sideloading exploit, then they can get code execution that way. And there's other places it'll look for as well. On the patch version on the right, to fix that, we move 800 into R8, and that serves as DW flags. That restricts and says the only place, like back to my analogy, if you go to look for the salt in the cabinet where it normally is or where it should be and it's not there, you stop. So it basically says if it's not in System 32, don't continue and try to find it by, trolling the operating system and looking for it. So that's how they fix this bug. So there's two problems that allow this bug to be exploitable. The first one is that they set the wrong DW flags. The other one is that they forgot the DLL in the first place. So Windows 10 64-bit did not have the DLL that was needed. So when you go to look for something and it's not there, that's why it keeps looking everywhere for it. This particular vulnerability affected Skype. It affected OneDrive and IE11 as well. So I'll do a demonstration of the exploit just to show you a working example. So I'm just shutting down IDA real quickly, and then, demo gods, sometimes they're not very friendly. We'll see what they're doing today. Maybe they're busy, hopefully in that room over there. So here I've got Metasploit running, and it's just a handler, and I'm sure most of you are familiar with Metasploit. It's an exploitation framework, and this particular piece I'm using says, I'm listening on a port, and I'm waiting for the victim to connect back to me so that the attacker can have access to that system. So that's all that's doing. Here's the victim right here, this Windows 10 box. And I might have to revert the snapshot. We'll try. But the idea is, imagine that you got an email, and of course you guys wouldn't fall victim to this, but imagine you got an email, the zip file, and it said, critical Skype update. You need to install this. So just double click on the installer and it will fix everything. Obviously people fall victim to this, or attackers wouldn't bother doing it. So I'm going to go ahead and extract this guy. So I'll say extract all. Just dump to that directory. And extract. So it just extracted it, and we go in here, and it says phoneinfo.dll. That is the DLL that's involved in the sideloading bug. It doesn't exist on Windows 10 64-bit base install by default. So what I did on this example is I used MSF Venom to create a malicious DLL, and this one, upon DLL entry, it will execute the interpreter code and connect back to the attacker system. This README is there is just to help people exploit themselves, so it's just a little announcement. Double click on it, please. And then as you can see over here, I've got OneDrive, IE11, and Skype. Those were the three that were involved in this bug. So I'll just double click on Skype Updater, and we'll go back over to the attacker system, and we hope that something appears. And there it is. So we're on that box. We're in the Windows 10 Skype phone directory. We go back over here. I love this part. If you look at Skype, it's sad. Like it knows it got compromised. So that's one example of, obviously taking a patch reversing through to exploitation. By reversing, obviously we cut a few steps. It takes a little longer than that normally. But let's go back out here, and I'll show you another one. This is one of the big ones that came out recently, right? MS17010. This was the infamous SMB1 and V2 bug that allowed for remote code execution. It's very rare that a service-side bug comes out these days. I mean, it's huge deal when they do. I remember one of the original ones when Metasploit first came out. It was MS03026, and it was one of the few exploits in Metasploit at the time because it was new. And you would just type your target, type your payload, type exploit, and you'd have a shell on your screen. And I remember the first time running it, I'm like, what just happened? I thought I had a shell in my own box or something. Like, you do it again, and you could just get shells all over the place. It was super easy, and that's because it was that kind of bug. And then MS was 08067 or something, and there's a couple other ones. This one was the new one of that because of the leaks that came out. You could send a crafted packet over SMB 445, port 445, and you would potentially get a shell. Those are huge. There were a lot of patches in this particular one associated with SMB, though. It wasn't just one little thing that they had to fix. So what we're going to do is just hone in real quickly on a information disclosure vulnerability that came out with that. Information disclosure typically means that we can send something to a service or a server or an application, and the response that it gives us is a little too friendly. And it might give us information, what was it? Heartbleed, I think, was an example that had an information disclosure because they didn't clear out and initialize the memory. What was sitting around and left resident there was meaningful. And we know as developers, you're told always to initialize your code. That's why functions like calloc, for example, memset, everything to null when it allocates memory to make sure you know what's there and there's nothing stale sitting there. Another big one was like null pointer dereferencing, where if you could get under the context of the kernel to go and try to execute code at memory address 0, then you could potentially get kernel code execution in a userland process. So Microsoft maps the first 64K, I believe, on starting with Windows 7 or so. All right, so this guy here, it says, an information disclosure vulnerability exists in the way server message block 1.0 handles certain requests. An attacker who successfully exploited it could craft a special packet, lead to information disclosure. In most situations, blah, 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 SMB 1.0, and then just apply the patch. So when you click on this particular update, you're going to get that cumulative update. Now this one I'm going to do the reversing on real quickly is going to be Windows 7. I don't have a working exploit of this one, but we'll still take a quick look. Just because I'm not going to spend my time on information disclosure bugs. So let me go back to Windows 7 where I've got IDA. All right, so right here I've just loaded server srv.sys associated with SMB. And if we were to look at where I got this from, let me show you the extraction. So we go to, this one was from March, I believe, so March x86, and we scroll down to SMB. And right here, version 1. Go in there, and that's where I just pulled that file from. So that's the extraction. I went and got the old version, and that's the one we've got loaded right now. And then the new version is right here. So that's the one we're going to diff against. So we go back to IDA. I'll hit Control-6. Diff database. Give me a moment. and we'll diff it against the new one. So this shouldn't take long at all because it's a pretty small file. It's only got 705 functions. To give an example, sometimes mshtml.dll can have 30, 40, 50,000 or more functions. It's a massive file to go through. So I'm just going to close these guys and then I'll zoom in. Now this one, a lot more code changes than that last example I showed you. So when I sort by similarity, you can see that most of them are the same, but up here we got quite a few changes. But that's way better than all these, having to go through everything, right? So we again want to look for things that look interesting. These WPP and this mangled stuff on the end, I don't know what that is right now. It's something used for function overloading or I don't know. But we want to look for things that have something intuitive in it. So we see stuff like server, SMB transaction. That looks interesting to me. So I'll go ahead and do a visual diff. And it's another relatively large function. So I'm going to zoom in, and then I'm going to duck my head down to find the bug, or what I think is the fix. Give me a moment. All right, so here's the bug that was fixed. Right here, this is the unpatched side on the left, and this is the patched side on the right. So you can see it runs this code, system disassembly here, and then it, on the unpatched version, it goes down. Oh, this is hard when I'm zoomed out. Give me a moment. Actually, I don't think it was the bug. Give me one more moment here. There it is. Whew. Took me a moment. So over on the unpatched version, down here you can see it runs this block of code, and then it goes down and calls a function called execute transaction. Over on the patch side, it has that same block of code, some code changes in it, but the same block, but it doesn't directly go down and call. There's no line going to that call to execute transaction like we saw before. First, what it does is it goes this way, and let me try to get there without screwing this up, and it calls memset. So that clearly looks like it's setting the memory before it allows some transaction to execute, so that way the memory disclosure is gone. So that's going to be all zeros now. So it's interesting, right? So let me see what time it is. We have a couple more minutes here, so I'll show you one last example. It's an oldie but goodie. It's used a lot as demonstrations and examples. I actually use it in one of my courses because it's really digestible. It's exploitable and it's digestible, meaning you can get it in one sitting if you're in that type of a class. So this was an animated cursor bug that came out back in 2007. It's a funny story because in 2005, EI Digital Security discovered the same type of bug in the same DLL, only one function away. Alexander Sotorov in 2007 was doing some analysis of that earlier patch in the file, I believe, and he noticed that one cross-reference away was the exact same bug. So if you would have just taken the time to do, it's really hard, Control X in IDA, and take a look, you would have found that bug. So that happens sometimes, and it's a little bit embarrassing for the organization involved, but it is what it is. So I'm going to go and try to load that real quickly. Give me a moment. So I'll look at the one for Vista. We'll first load the patch version in. And we're going to go to a function. Actually, I'll diff it so we can see what's going on. So let the diff run. It won't take too long. It's a Vista file, so it's not very large. This has 2100 functions in it, so we'll go close this out. And here are the results. So let's zoom in. Sort by similarity, it's another easy one where there's only one change, right? So load ANI icon. That's what I'm saying by function names being useful. Load animated icon. You know what that does then. So we go ahead and load up a graphical diff. And there's a few changes in here, so let me identify it real quickly. And here's the patch. I have the patched version on the left this time, and you can see there's this comparison here. It says compare some offset in memory on the stack to hex 2.4 before you actually then call a function called read chunk. Read chunk's right there. On the unpatched version over here, you see that same call to read chunk, but when you go up, there's no check to 24 hex against some stack variable. So that's a bounds check there. And what this leads to, I'll show you. So I'll go back out of here. And we'll go to load ANI icon. So here's that function that we're just talking about. It's pretty large if you zoom out. And you can see here is that comparison to 2.4. So we're looking at actually the patched version right now and not the unpatched version. And the unpatched version that doesn't exist like you just saw. And then it calls read chunk. What happens when it calls read chunk then is we go and call a function called read file pointer copy, which leads us to a call to memcopy, and that's the problem. Memcopy's taken the size argument based on a stack, something on a stack. And if an attacker crafts a malicious animated cursor and it gets loaded by a browser, then it will trust what's in that animated cursor as the size. And memcopy's like, okay, I got it from there in memory, so I'm just going to copy as much as you asked me to, and it results in a buffer overflow. And what that check does is says it has to equal hex 2.4. That should be the size of the animated header. So you can't craft a malicious animated cursor this time. And the funny part that I was saying is if we do a cross-reference to the beginning of this function, and now we're back to the caller. So what I just did is I said, who actually calls the function load ANI icon? And it's a function called load cursor icon from file map. So here's where that call occurs and where they put the patch. If we zoom up and follow back earlier on, you can see that same exact thing happening again. Compare ANIH to something on the stack, and then do that sanity check, the little validation, and then call read chunk. That's what I was saying. By one function away, that same bug existed, and they just didn't notice it, and it took 2 years to discover it. And these bugs sometimes sit around for a very long time, as we've seen. All right, so that is the end of the presentation. It is 2:53. I definitely have time for a couple questions if anyone has anything to ask. Otherwise, thank you very much for attending, and hopefully I'll see you again sometime. Yep. Jeez.
Where's a good way? How is there a good way to practice?
A good way to practice is well, you can Google around for examples of people who have done patch diffs publicly. Like, look at people like Joxine Corrette and other folks who have released those kind of things publicly. There's starting with one of the earlier patches, something that was relatively easy, you know, and going through an easy example like I was just showing you. Yep. Where can you access the PowerPoint? I don't know where it gets posted yet. I think it's been recorded, right? Okay, yeah, it'll be out. They'll tweet it.